Good morning student, welcome back to my channel The Science Station. In earlier session I explained you Heisenberg's uncertainty principle and we find the expression for that. Today I will explain the experimental illustration of uncertainty principle. मतलब experimentally हमने कैसे हाइजेनबर्ग अनसर्टिनिटी प्रिंसिपल निकाला आई विल एक्सप्लेन इन टुडे सेशन. Before starting my session, please like, share and subscribe my channel The Science Station. One more thing, if you have any doubt related to topic, you can just drop one comment. Definitely I will answer. Please drop comment or any queries, please write in comment box. Definitely I will solve your query. Let's start our session. Today's session is experimental illustration of uncertainty principle. See, this is our experiment. Here we have one microscope, observer मतलब we are observing from here. This is inside the microscope. ये पूरा बॉडी है माइक्रोस्कोप का एंड दिस प्रोसेस इज गोइंग ऑन इनसाइड द माइक्रोस्कोप. ये हम ऊपर से देख रहे हैं, यहाँ से हम देख रहे हैं. वन इंसिडेंट फोटोन है विच इज़ इंसिडेंट, यहाँ पे इंसिडेंट होता है फोटोन. थीटा, फ्रॉम थीटा एंगल दिस फोटोन स्कैटर्ड ईयर एंड दिस ईयर. अगेन यहाँ से फिर से स्कैटर्ड होके दोनों यहाँ मिलते हैं, देन अगेन स्कैटर्ड और यहाँ पे हमको दिखाई देते हैं. फर्स्ट इन वन फोटोन इंसिडेंट ईयर, इट विल बी रिफ्लेक्टेड और स्कैटर्ड बाय थीटा एंगल ईयर. Then again they are scattered photon is again reflected here and they meet here. Again same process will happen and observer will observe all these things inside the microscope. Okay. For this we have two cases. First case, consider a case of measurement of position of particle. Measurement of position of particles means in this case we are having delta x. Consider a case of measurement of position of particle when electron in the field of microscope. The resolving power, that is the smallest distance between 2 points that can be resolved by the microscope, given by this delta x equal to lambda upon 2 sin theta. Theta is the semi vertical angle of the cone. Here you just check here, theta is the cone. So first one, this one, that is equation number 1, where lambda is the wavelength of light used, theta semi vertical angle of cone of light, delta x uncertainty in determining the position of particle. Now we have case 2. What is the case 2? I already explained you how it works. फर्स्ट केस में क्या था, हमने ओनली डेल्टा एक्स से लिया कि कितना हमारा मेजरमेंट ऑफ पोजीशन ऑफ पार्टिकल कैसा दिया जाएगा. दैट इज़ 2 साइन थीटा. वाई साइन थीटा? आपने पढ़ा होगा AC इन DC करंट, यू हैव अ वेव. Wave nature is only described by sin theta. That's why we are using delta x equal to lambda upon 2 sin theta. Why 2 sin theta? Why 2 sin theta? Why 2 sin theta? Because we have 2 times 1 sin theta, 1 sin theta. That is lambda upon 2 sin theta. Now case 2. What is the case 2? In order to observe the electron, it is necessary that at least one photon must strike the electron and scatter inside the microscope. Same thing I told you, one photon will be hit this electron. Only in that condition that the scattering will happen. Momentum is given by h upon lambda. After scattering enters the field of view of microscope. मतलब scattering के बाद जब हमें दिखाई देगा p momentum से p equal to h upon lambda. Anywhere, it may be anywhere with 2 theta, 2 theta, Thus x component of the momentum is given by px. It will be p sin theta minus p sin theta. We have this such type of components. Here we have p sin theta, here we have p minus p sin theta, x minus x, y minus y. Okay. As the momentum is conserved in collision, जब ये टकराएंगे, as the momentum is conserved in collision, the uncertainty in x component will be px equal to p sin theta minus p sin theta, that is 2p sin theta. So px equal to 2h lambda upon sin theta, because we know that. From equation 1 we have delta x equal to lambda 2 sin theta. 1 and 2, this is our equation number 1, this is equation number 2. Delta x, delta p equal to this value, we can cross the value, px equal to 2 sin theta. We have only h, which is h is constant, Planck's constant. This shows that the product of uncertainties is position and momentum is order of Planck's constant. Okay, now this is the experimental illustration. Again I am explaining you. See, here we have electron, one photon is incident on it, so that the photon will scatter in one direction theta, in other direction theta, that is plus theta minus direction. Case 1 we have lambda upon 2 sin theta for delta x, because why sin 2 sin theta, where here and here sin theta plus sin theta. Okay, in case 2 p equal to h upon lambda, px will be the px may be the p sin theta minus p sin theta, that is p sin theta minus p sin theta. Again we did the same thing. As the momentum is conserved in collision, px equal to p minus, that is 2p sin theta, px we get the value of this by putting the value of p. Equation 1 and equation 2 we get this. This show that the product of uncertainty in position momentum is order of Planck's constant. Now significance of Heisenberg's principle. First, Heisenberg's principle is significant for microscopic particle. Means this uncertainty principle is only for microscopic particles, means particles are very small, for that only it works. Second, according to this principle, the energy of the photon doesn't affect the only position, velocity of large object when they comes in contact with the photon. See here, from here the position doesn't affect. Till here you have Heisenberg's uncertainty principle. In earlier video I explained the Heisenberg's uncertainty principle and we derive one expression. In this video there is a illustration of experimental illustration of uncertainty principle. These two questions are very important. Till here Heisenberg's uncertainty principle topic is over. In next video I will explain you Schrodinger's wave equation. Again this is very important topic, and a wave function also. Till there, be with me, like, share and subscribe my channel The Science Station. Again I am repeating you, if you have any doubt regarding any topic, please comment me in comment box. Thank you so much.